Hola, ¿cómo estás? Today we're going to be talking about this initial value problem. X double prime plus 6x prime plus 9x is equal to f of t, where x of 0 equals x prime of 0 equals 0. So the first thing is to go over our Laplace table and see what we need. So we need number 18 over here. We need to apply number 18 to get an initial head start on this problem. So, um, basically, there are two key things we have to know in order to start this problem, and that is that the Laplace of f double prime t is equal to s double prime s squared times f of s minus s times f of 0 minus f prime of 0, and the Laplace of f prime of t is equal to s times f of s minus f of 0. And f of 0 and f prime of 0 is represented by x over here. So applying this to our problem, we can say that x double prime can be expressed as s squared times x of s minus s times 0, since x of 0 is 0 and x of 0 corresponds to our f of 0 here. Minus 0, because again, x prime of 0 is 0, plus 6 times s times x of s plus 9 times x of s, because the Laplace of x of t is equal to x of s simply. And all of this is equal to the Laplace of f of t, which is equal to f of s. We can rewrite this long equation by factoring out x of s. So factoring out x of s, we have s squared, and these two are zeros, so we can cancel those out. Plus 6s plus 9, and this is equal to f of s. And dividing both sides by this polynomial, which we can further express as s plus 3 squared, we get that x of s is equal to f of s over s plus 3 altogether squared. And now we can apply the convolution. Oops. The convolution to this simplified equation. Uh, we can apply the convolution, and what will that look like? So you'll write apply convolution. So the convolution theorem simply states that the Laplace of small g convoluted with f of s is equal to g of s, big G of s, times big F of s. And thus we can identify x of s as f of s times 1 over s plus 3 squared. And we can further find that the inverse Laplace of f of s is equal to f of t, and that the inverse Laplace of 1 over s plus 3 squared, according to our Laplace table, is given by, let's go to our Laplace table briefly, is given by, I don't know if you can see, but it's given by, Let's see if we can find it. By this one, number 11, where t to the power of n times e to the at is equal to n factorial over s minus a to the power of n plus 1. So let's write that down over here. So it's mm, so this one is given by let me see. So over here n is equal to 1 and a is equal to -3. So this means that um the inverse Laplace is t to the power of 1 times e to the -3t. And I'm going to try to make this disappear for a while, then come back. Um, there we go. So we find that it's equal to t to the power of 1 times e to the -3t. And this is equal to f of t, which is equal to um, x of t, taking the inverse Laplace of x of s as well. Because what we do to one side, we must do to the other side. Uh, Equals inverse Laplace of x of s equals x of t. So writing everything down, we see that um, wait, actually, f of t is not equal to x of t. This is just finding our two separate forms. And then x of t will just be equal to f of t times t times e to the -3t, which is equal to b, as we see over here. And thus b is the correct answer. Thank you for watching this video, and we'll see you in the next video.